Hi everyone. So let's discuss about some of the more array manipulation related functionality like let's say you want to append some data or some element to your existing NumPy array, or you want to insert at some particular position, or at some particular position you want to delete some elements of array. How you can perform. So I have already imported this NumPy array. Let me just create first a one-dimensional array and we'll see all those operations. Then we'll see for the two-dimensional array. Okay, let's create a one-dimensional array. So let's use the very simple a range. Let's say 10 to 19 values I want to generate. So now I have a is equal to 10 to 18. Now let's say I want to append some elements just beside this 18. So in that case I can just simply use like a append. Now the first argument will pass it in which array you want to append, and the second argument you will pass it like what are the values you want to append. So let's say I want to append values like a 20. Okay, so I have kept it inside the list. So you can see I have got this 20. Let's say more than one element I want to append, so it will be 21, or let's make it 21 and 22. Now you can see we have a 21 and a 22. Now you can see that after this appending operation or any kind of operation we'll see in this video, it won't change the original NumPy array, so no effect will come in the source NumPy array. So in that case, whatever the NumPy array it will return, you just grab it into another variable. So that is how you can do on a one-dimensional data. Let's create a two-dimensional data. Still, if I just print this a, we have a total 9 elements. So let's make another array, let's say b, and I'm just going to reshape the original one. Let's reshape it to 3 cross 3 array. And if I just display b, now I have a 3 rows and a 3 column matrix whose values are 10 to 18. Now let's say I want to add like 3 more elements to this particular array. So I can just simply use np dot, let's say, append, let's say b, and values I want to append. So let's say 50, 51, and then let's say 52. So now you can see it has almost flattened out this original array 50, and it has given us like a 10 to 18, and then it has appended 50, 51 and 52. So it has not appended at some particular specific axis. But now suppose if you want to append this 50, 51, 52 on a row level, so after this 3 row, on a 4th row you want to append this 50, 51 and 52. Let's say you want to put this 50, 51 and 52 into last row. So after this row 16, 17 and 18, you want to keep this 50, 51 and 52. So you can just simply use it this way, and you can just wrap it up into another brackets. Okay, so it will behave like a one row or a one column, or I would say some one-dimensional array. Along with that, another argument you need to pass it like axis is equal to 0. So axis is equal to 0 corresponding to rows wise, and if I just execute it, now you can see it has appended this 50, 51 and 52 along the row, along the last row I would say, when I pass this axis is equal to 0. Same thing if I use it, but let's say it axis 1, and let's see the result. So you can see immediately it has thrown us the error, because when I want to append it at a column level, like along with this 12 there should be a 50, then along with this 50 there should be added 51, and along with this 18 there should be added 52. So in that case this all 50, 51 and 52 should be like an individual element. Okay, and let me just execute it. Now you can see we have got this 50, 51 and 52 along the column. So that is how you can append the individual element or a rows of element or a columns of element in your existing array with the help of this append method. Now let's see about the another one, like a insert. So append is like you are appending last index position available in a NumPy array, whereas inserting means you can insert some data at any particular index position. So we have already A is available with us. Now let's say I want to insert, so for that I am going to use the insert method. So here I have to pass the 3 arguments. So the first is in which array you want to do the insertion. Next is at which particular position you want to do insertion. So let's say this is the first position, this is the 0th position. So at the first position I want to insert, let's say the value like 100 or minus 100. So now you can see at the first position it becomes minus 100 and remaining all values of this particular NumPy array A got shifted right by index position 1. So now you can see remaining all are same in 11 to 18, but index position has been incremented by 1. Let's apply the same thing on a 2D array. So we have already 2D array available with us, so delete it. Okay, let's use the insert same function. Let's say B, and I want to insert this minus 100 at, let's say, same position 1, and I want to insert this minus 100. Now this one single index position in case of 2-dimensional array doesn't make sense, but in that case it will just flatten out this full array and it will give us the exact similar result. But let's say you want to insert this minus 100 to some particular sets of rows or some particular sets of columns the way we did earlier. So let me just select it. Now along with the row, let's say I want to insert, so I can just simply use like a x is equal to 0. So that means that at the first row every single value it will insert like a minus 100 and x is equal to 0 indicate at a row level. Now you can see one more new row has been added or inserted, I would say, at a first position. If you want to do it at a second, you can see at the second row it has inserted. Now let's do same thing at a column level. So now you can imagine that at the second column it will insert minus 100. So this is the first 0th column, this is a 1 column, and as after that there is a minus 100, and then we will get this 12, 15 and 18. So you can see we have artificially inserted this minus 100 at a second column. Okay, so that is all about the appending of elements inside this existing NumPy array and inserting element at some particular position in 1-dimensional array and at some particular rows and a column in a 2-dimensional array with the help of insert method. Now let's see about the delete. So same NumPy array we are going to use like a. Let's say I want to delete some particular element, so I can just use like np.delete. Let's say the array in which you want to delete something, so that is a first argument we will pass, and let's say I want to delete this 12, so its index position is 2. So I will just simply supply the index position as a second argument to this particular function. Now you can see we have one less element, so we have got 10, 11 and then directly 13. This 12 got removed. Okay, same way we will apply on a 2-dimensional array. So np.delete, let's say B, which particular row you want to delete, because now every single number or column got reference with the 2 numbers in this case. So let's use, let's say, first row I want to delete it, so 13, 14 and 15 will be removed. And if I just keep it like x is equal to 0, that means at a row level, so it's a 10, 11, 12 and 16, 17 and 18. Same way, if I just reverse it like x is equal to 1, so it will be applied at a column level, so the first column will be removed. So I will just get 10, 12, 13, 15 and 16, 18. You can see exactly similar reason. Let's say if I want to delete the second row or a second column. So I got 10, 11, 13, 14, 16, 17. Okay, so that is all about the 3 operations we have learned in this video, like how to append the elements in existing NumPy array, or how you can insert element at some particular position, or how you can delete element at some particular position of the NumPy array. So that's all about this video. See you into next video.